Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 141. 5 maximum removals from source string. Yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. Yeah, so basically, this is a dynamic programming problem. It took me a while to get, and honestly, I had to implement this bottoms up. I actually should have saved it. I didn't submit it, but I actually did this tops down. So we'll do it together, top down again, and I think it's a easier way to understand it. Though the implementation is a little bit tricky, and you have to convert it to tops down. Let me actually open another window real quick so that I can kind of keep the old code. But yeah, but I think the part that I struggled with was that I thought we had to iterate on target indexes, but actually that's not true, right? Oh well, actually let's step back a second. Is that both the source can be 3000, pattern can be 3000, and target index could be 3000. So if you try to do some DP based on this and this, then it's going to be n cube, and that's going to be too high, or 3000 cube anyway. But the first thing I noticed after that, and it took a while honestly, is and today's just not a good day for me. Some days it happens because I feel like these problems are usually my strengths, but today not so much. But anyway, the key is noticing that you don't need to iterate through these, right? These are just in a way the forbidden indexes, right? These are indexes that you cannot visit. And if you kind of keep that in mind, then you just have to figure out how many of these we can do to make it forbidden, and then still having this maximal, or that the rest is gives you a subsequence. And you can roll this all into a dynamic programming with what I always call a tick no tick. People have been kind of taking that term. I think I started it, but maybe I'm wrong. I lied. But I actually stole that from chess, where I think, Hakaru is just like tick 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 tick, and I'm always thinking now DP problems is like tick no tick. But yeah, basically, given S is the length of source, P is length of pattern, and you have all these things, right? You can have S of index, P of index, and yeah. And for this particular problem, or for this particular video, I'm not going to go over dynamic programming itself. I'm just going to go over the recurrence. There are a lot of dynamic programming problems on Leetcode, and at least for the daily problem especially, I go over a lot of them. But I just don't want to, spend another couple of minutes talking about dynamic programming. Suffice to say, if you don't know dynamic programming, that is a prerequisite. So there's no, you may think you understand it, but if you don't, then you just don't, right? So come back later, it's fine, because people always ask me why I don't explain everything from first principles. But yeah, anyway, so defining this dynamic programming function, we have you can define it in a couple of ways with equivalently with just these index. One way to say this is that we are at source of S index and pattern of P index. What is the maximum score, right? The score being the number of target indexes that we can take. But it's a little bit tricky because you want to be as precise as possible. But and this doesn't really convey all the ideas that we have, right? Which is that another way to write this would be actually we already matched S or source of up to S index and pattern of P index. What is the maximal score for the remaining indexes, right? So I think this is a little bit more precise in that it tells you the precondition of this function, which is that the prefixes are already matched up, right? So okay, so then given this, now we can think about the base cases, which is that if the pattern is equal to P, that means that all the patterns are matched. But in this case, well, in this case, source can actually still have characters left, right? And that's okay. Our condition is met. But our source having characters left, that means that they can still match target of indexes. So we have to keep that into consideration, because that's not, like there is an extra score left, right? One thing I skip is that I just put everything into a set so that this is an O of 1 lookup. And I wrote F for forbidden. That's, I don't know. So anyway, so then now we can say, in this case, if P index is equal to P, then we just go through source one at a time. And you could do this recursively. You don't have to. I think either way should be fine, because there are not that many cases. Like I think it adds an n square layer if you really do it sloppily, but that's fine. Right, so then now, if current index is in F, we get a point, right? So basically, if S index is in F, then we can return go of S index plus 1, P index, and P index is P. Oh, plus 1. I said plus 1, but then I think I just got confused with this plus 1. Otherwise, you just return it without the plus 1 score, right? And then the other base case, of course, is if this is equal to S, that means that the actual string is done. So if P index is equal to P, then we return 1 because we have one way to do it. Oh, no, sorry. We return 0 because we're done and we're happy, we're accomplished. Otherwise, we return negative infinity because we want to say that, okay, well, you got to this state, but it's not possible because we haven't matched any of the pattern, or not all the patterns yet, right? So those are basically it. And then now you have a tick no tick thing. Tick no tick. Right. And I guess we'll separate them out. I don't know why I wrote it in the same line. Yeah, and tick is if well, there's just some couple of cases, right? So we set in best is equal to negative infinity as a standard no value, and then I'll take it. Well, there are a couple of cases actually, more than just tick no tick, but because there's actually tick from pattern, right? So we tick from pattern, then yeah, if source of S index is equal to pattern of P index, then now this is a possible answer. So then now we do a max of best, go S index plus 1, we move on to the next one, and P index plus 1, right? And then the other one is tick from target indexes, right? So then if S index is in F, then we can maybe consider this, right? So we go S index plus 1, we don't move P index, and we add a plus 1 here, right? And then the other is just no tick, which is very basic. We go S index plus 1, P index, and that's it. So we don't take it from pattern or target indexes, and we're very happy at this point. And then we can start, kick it off at 0, 0, and that's pretty much it. That's the DP, unless I'm wrong. All right, let's give it submit. Someone told me that when I did this during the contest, I was worried it would run out of memory, and as if on cue, yeah, it runs out of memory. Someone told me that you could do like a cache clear thing. I don't know. I don't like to do it this way, so I don't. But let's give it YOLO submit. I don't know. But this is the reason why I don't know, right? Someone on my Discord told me that it would work. They lied, or I don't know. Leetcode is just inconsistent. Who knows? But yeah, but that's basically the idea for this one. And for me, during the contest, it took me a while to get here, and I just spent another 5-6 minutes to convert it to bottoms up. It may be intimidating to look at it bottoms up, and actually, to be honest, I don't know if n square space would be fast enough. So I kind of took my time with this deliberateness. But the idea is actually very similar, is that, you iterate the way I have a video about converting it from top down to bottoms up, but the way that I did it, this one, and you can watch me solve it live during the video as you kind of see my thing, is that I basically look at the direction this goes, right? This goes from index +1 to p index, s index +1 to p index +1. That means that every x, for every index on the first dimension, you take it from the future. That's how I got this thing where you count it backwards, right? Because basically that's, you know. This is the base case. Even though it looks very simple, this base case encapsulates or these basically these things, really. Well, this thing, yeah. And then the other base case. This is the other base case, which is here, right? Because s index is equal to this is if p index is equal to p, then this is, you know, this is what happens, right? And then now for p index, and I did the space optimization, which I'm not going to go over that detail, but this is just the previous row and the previous DP, as I call it, which is the s index +1, right? So PDP contains s index +1 is what we have here, right? And then now everything else is just a copy and paste, right? So if they're equal, then we do s index +1, p index +1, which is what it looks like here, right? Take it from the forbidden, right? This is the same, right? P index, take it from s index, p index, or s index +1, p index at the same, +1 here, which is what we have here. And then the no take, we just take it from the previous index, and that's why I have it here instead. And then at the end, I make a copy of it. Technically, this deals some stuff with garbage collection, which we're not going to go into, but you could do a for loop to actually make sure that it is clean. But yeah, that's all I have for this one. What's the complexity, right? It's going to be s times p, as you can see from, I mean, it's much more clearer from the bottoms up, I think, for time. And we did do this space optimization, so the 2 arrays instead of n arrays. The key thing to note is that you always look at the previous, in this case, s index +1, here, right? So, you know, so that's why we can do the space optimization. And it is only over p space. So yeah, that's all I have for this one. Let me know what you think. Yeah, I mean, honestly, a little bit of a retro. It took me 17 minutes to do this one, and it feels kind of bad because I feel like, like I said, this is kind of stuff that I'm very good at. But you know, some days you're gonna have bad days, and all you can do is keep showing up and hope your practice will carry you to more good days than bad days, or at least get enough sleep, because I didn't. But anyway, that's all I have for this one. You can watch me solve it live during the contest now. Okay. Oh, how many people have gotten it? 142. Maybe there's a dumber way. Or maybe people just did the math and I did it the dumb way. Okay, 5 people got this. How many? 14 people got Q4, so we have some time. We're a little bit slow today, but that's fine. Okay, read the bomb. A pattern that's a subsequence of sorts and is sorted contain distinct numbers. Removing a character targeted. Okay, so we why can't we remove, oh, because I this is probably just DP. I don't like that they weigh 3000 like this though, but is it DP that? 18 people, 13 people, that's gonna be it. target in I mean, it's okay. AB. How am I thinking about this? ABA. Can I do this one? Let's see. Yeah, more people got it. Oh, I haven't even read the problem yet, but I want to focus. Focus. How do I even think about this? Target indexes matter, maybe. So that's N. Excuse me. And we say, can we remove this? Do we always want to remove in order? So target indexes and source, right? That's n square. We remove the thing, and then we that's n cubed if we do it sloppily. I got it, but I think it's n squared, but I don't know if I could write the bottoms up quickly though. So and tops down may be too slow. We'll see. Also 0, I suppose. And then, okay, so then it's take no take, right? So what am I doing? It's okay, so if the invariant is that we're here because we can't do the rest of the pattern. Oh no, is this even right? Because we have to. No, we have to keep track of the pattern index. Maybe. At least the way that I'm thinking about it. You can't just. And it is 3000. Alright, let me skip ahead. I don't know. Actually. More people's gotten Q3 now. I still haven't read it yet. Okay, so this isn't right. Because we have to keep track of pattern to test. Do we though? No, I don't think so, Larry. You're wrong. I think we need. Also, this is like terrible. Name it. No, you don't need to do it this way. You know, this is deterministic, right? So you only need. Return, then we're good. So return 0. No, we want to, yeah. Otherwise, return negative infinity. Yeah, 9 is fine. We return negative infinity because it's just not possible. Right when we get the max. Okay. And then now, yeah, okay, I see. This is actually not that bad, I just get confused. Okay, then now for, no, I don't even need to do it this way. This isn't T, this is just, right. Okay, you got this, I think. Okay, so if S index is in F, then if this is not in F, then we can just return go S index plus 1 P index, maybe. Well, you have to decide if you want to match it with the pattern, so that's the thing, right? Okay, fine. Okay, so then now think about the cases. I'm taking it way slowly. I should do this faster, honestly. Okay, because you got this now, Larry. Okay, so then now if source of S index is equal to pattern of P index, then we're good at matching at 1. So let's match this one. Yep. What are you doing, Larry? Why are you struggling so much in this foot? Okay, so then now we also want to just go in general, go S index plus 1, P index, we don't care, we don't match. And then now there's a forbidden thing, which is that if we can do it, then if S index is in F, then now we can say, okay, we remove this and we get a score of 1. I don't know why I struggle with this one, but yeah. Whether this is fast enough is hard to tell, but pattern P index. Oh, I thought I had it. P index is equal to P, then we can also return 0. Well, no, it's not, because it could go to, we actually want to return go S index plus 1, P index, and then this will always be P, but if S index is in F, then we return go S index plus 1, P index plus 1. I think this is a little bit better. Not good enough apparently. Oh, I just have like a weird thing. Did I tap my max? 1, 2, 0, 2. Okay. Alright, that's fine. So then now sources. Is that too slow? It feels slow. And we only have n memory limited exceeded, which is not great. Okay, fine. But now this is straightforward. How many people got it? 80 people got it. I'm not surprised. So I have to rewrite this. Let me open a new window just in case I lose it. Okay, so then okay, fine. DP S index is always dependent on P index. Okay. Alright, so which one do we have first? P index, S index depend on the previous. Okay, that's fine. Okay, we have to fill out the thing first. If S index is then P is equal to, okay, fine. I can't believe I have to write this twice because Leetcode refused to like time sign stuff, but okay, fine. Times P plus 1. No, S. For HS, there's P. Okay, I think this is right, but it's really awkward looking. Okay, so dp of P is 0, 0, and then now this is going to be P minus 1. dp of P index is you go to negative infinity. I guess that's what this means. Okay, fine. And then now, yeah, okay. Am I prematurely optimizing? Probably. I guess this part is pretty straightforward, actually. Okay, so then now, P, actually dp of P is equal to PDP of P, maybe, if S index is an F, then dp of P plus 1, right? And then now you have this thing. You have dp of P index is equal to PDP of P index, okay? If yeah, whatever, nested it. P is greater than dpp index. Okay, and then now one last more. If S index is an F, we probably could remove this loop for whatever, but whatever. If and then S and this should be, how did I have it? S index is equal to S. This is when it's equal to S, right? So yeah, that's really it. Okay, so that looks good. Again, let's try the 3000. Is this fast enough? Alright, I mean it's faster and it doesn't run out of memory, which is good. Alright, that's YOLO. Hopefully not too okay. A little bit slow, but we got there. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. My explanations are pretty good. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.